Good afternoon, students. Today I am going to start with the instruction with the previous one lecture in parallel to the previous lecture instruction, that was move instruction. Now today we will do the add instruction. Okay. In 8051 we use the add instruction as an your template, or the instruction format is written like this: add a comma source. Okay, add a comma source means the source contents will be added to the accumulator and the final result will be stored in the accumulator finally. So it will be written as add a comma source. Okay, now this is the format in which we can write our add instruction. And always the accumulator will be the destination. In any arithmetic operation, destination will always be your accumulator. So with this, I have written some of the examples for that. First is move a comma hash 25h. What is the meaning of this instruction? The meaning of this instruction is that 25h data hash indicate pound sign indicates that is the directly data which is given. So this will be act as your source, means data, and this data is to be copied into the register A. Okay, after the execution of this instruction, the accumulator content will be definitely equal to your 25h. H means hexadecimal. Now come on to the next command, that is move R2 comma hash 34h. Okay, what is the meaning of this command, or what this command will done? The 34h data is to be copied into the R2 register. So after the execution of this instruction, R2 will contain your 34h, and accumulator was at 25h. Now the third instruction is the add instruction. Firstly, if I am talking to someone that add the two numbers, so first number is given in the accumulator and second number is given in the R2 register. Now I will add these two numbers by using the command add a comma R2. Add a comma, this is R2. Okay, what is the function of this command? This command will add the contents of accumulator and the register R2, and final result will be stored in the accumulator itself. As I have already told you that in all the arithmetic operations, even though it can be your subtraction also, it can be your multiplication also, it can be your division also, in all the arithmetic operation, destination register should be your accumulator. So in this case, if I will add these, 5 plus 4 is here 9, 5 plus 4 is here 9, and 3 plus 2 is here 5. So accumulator, after adding the operation, accumulator content will be 59h. Okay, and this is the addition done in the hexadecimal. Hexadecimal addition is done in this process. Now this is a program to add two 8-bit numbers. As you know that 8051 is your 8-bit microcontroller. So we have to add these two numbers. Firstly, I will move first number into the accumulator, second into the R2. Then I have written the command add a comma R2. Okay, here I am using the three commands, but this addition can be done only two commands also. Okay, so how is it possible? This is the another method. It will also operate as a addition purpose, but using only the two commands. How you can see, now you can see that in this command, first command, I am copying the 25h into the accumulator. Now the second command, as I note that now the accumulator content will be 25H. Okay. And now after this command, I have written this. Now after this command, accumulator will contain 25H. That is 25H. Okay. Accumulator will contain 25H after the execution of this instruction. Now, what this instruction will do? After this instruction, add a comma hash 34H means this instruction will add the content of your accumulator and 34H directly without moving this into any other register. But in this case, I have moved 34H into the R2 register. There is no need. I can also, source can be your directly data. Okay, source data can be directly given by using the pound sign. So in this command, again 25H plus 34H, after the addition of that 25H and 34H, I will get 59H. And after the execution of instruction, accumulator will be updated to this value. A is equal to 59H. So this is the operation which is to be performed. So add instruction actually tells us the CPU to add the source byte to the register A and put the result in the register A and put the result in the register A. And the source, actually the source operand can either be a register or an immediate data, and but the destination, your destination in which result is to be stored must always be your register A. Now these two commands, you can see these two commands are invalid. These two commands will be invalid. These two commands are invalid because why? I have already told you destination register always and always should be your accumulator. But in these two instructions, destination register is R4, destination register is R2. So that's why these two instructions are invalid in the 8051, because in any arithmetic operation, the destination register should always be the accumulator. So this was the explanation for the add instruction. Now some of the other instructions I am writing for the add. Let us suppose move R5 comma hash 25H, move R7 comma hash 34H. Now move A comma hash 0, add A comma R5, then add A comma R7. Now what does this program operate? I will tell you. Okay, by instruction, one by one, each of the instruction after updating or execution of each instruction, after that what the content will be that particular register will contain. Okay, in this first instruction we have to move or copy the 25H data into the R5. After the execution of instruction, R5 register, as you know that in 8051 we have A register, then B register, then R0 to R7. These all are the your 8-bit register, whereas two 16-bit registers are always there in the 8051, that is DPTR and program counter. So In this, after the execution of this instruction, R5 is equal to your 25H. Now come on to the second instruction. The second instruction is your R7, move R7, hash 34H. Now in this instruction, after the execution of this instruction, it will copy the 34H data directly is to be copied into the R7 register. And after the execution of this register, R7 will contain the 34H. So I will update R7 as 34H. Now move a comma hash 0. As you have seen that here H is written, here H is written, but nothing is written over there. It means this is the decimal data. Okay. And you know that 0 will be written as 0 in the decimal and 0 always. And in hexa it is also written as 0H. So actually if there is not written anything, then this by default this data will be treated as your decimal. So after the execution of this command, accumulator will contain the data 0H. In hexa, it will be also 0. If your number is 0 in the decimal, the hexadecimal representation for the 0 in decimal will be always 0. So after this, accumulator will contain 00H. Why I am written 00? Because you know that in hexa, each one of the digit is represented by 4 bit. So this will be 0000. This is also written as 4 times 0. So total 8-bit data is there. Total 8-bit data is there. So now come on to the next command. Next command is your add a comma R5. Okay. So in this process, cumulative content will be A is equal to, final cumulative content will be equal to A plus R5. That is A. The value for the A is here 00. So 00H plus R5 content. R5 is here 25H. So 00H plus 25H will give you 0 plus 5 is 5, 0 plus 2 is 2. This will give you 25H. So after the execution of this command, A will contain 25H. Okay. Now the last command is here add. This is add A comma R7. Now I have to add A and R7 content. Now I will take A as 25 because this is the updated value of your accumulator. Now I will not take the value for the 00. The A is updated by the value that is 25. Now A will again perform the operation. A is equal to A plus R7. Now A is here 25H and R7 is here 34H. Here you can see R7 is here 34H. So after the addition, this is 5 plus 4 is here 9 and 3 plus 2 is here 5. So 59H data will be stored finally in the accumulator. So accumulator value will be updated as 59H. So this is also the another way. But here we have used 1, 2, 3, 4, 5 commands. In the very first program, today I have already discussed, we have used this operation. Same answer will be get by the 3 instructions. In the second program, I have used the 2 instructions. But in this program, same operation is done by the 5 instructions. Now, which one is the best programming? The best program is that in which only 2 instructions are used. So that's why also your programming part should be so much efficient that you can do your task by using the less number of instructions. So in the second, which I have already discussed with you, the program which perform the addition with two commands, that is the efficient one. That was the efficient one. Here this again, this same procedure is done by 5 instructions. In the very first it was done by 3, and the in middle I have already discussed with you this operation using the only the 2 commands. So second one method is the most efficient method, in which we have used the less number of commands to do a operation. So this is completed with this. So now I will do the next. Now I will do the next concept, that is structure of assembly language. Next concept is structure of assembly language. Structure of assembly language. Okay, actually, you know that in the early days of the computer programmers, actually we have used the coded the programmers coded into the machine language in the form of your zeros and ones, and that method was your tedious, slow, and prone to the error, because everyone, the data written is in the 0 and 1 form, can't be understand. So the solution for that is we used the assembly language there, so which provided actually the mnemonics, like if you want to do the movies, if you want to do the copy the contents to the any register, then you have to use the mnemonic as move. Okay, then if you want to add two numbers, then you have to use the mnemonic as ADD add. So assembly language, actually your assembly language is which provided the mnemonics, actually which provided the mnemonics for the machine code instructions, and plus other features also, so assembly language programming actually consists of your lines of assembly language instructions. Like in the previous, I have already discussed with the addition program, addition of two 8-bit number program. So you have used the assembly language program instructions. A series of lines of your assembly language instructions were there. In the first program, you have the 3 instructions. In the second program, you have the 2 instructions only, and in the third program you use these 5 instructions. So assembly language actually is your low level language. Assembly language is your low level language. Okay, because actually why this is low level language, because it directly deals with the internal structure of your CPU, that is the CPU used by 8051. So it is directly related to, or you can say it is directly deal with the internal structure. Means how much registers are there, how much registers are 16-bit, how much registers are 8-bit, how the instructions will be moved. So every knowledge of that, how many input output ports are there, how many input output pins are there, so directly deal with that. So internal structure, directly dealing with the internal structure, that's why this language is known as your low level language. Okay, next is your, so assembly language actually consists of your mnemonic is there. Okay, so mnemonic is there. Actually mnemonics, what is the mnemonic? 3 words in the instruction, in any instruction is used: mnemonic, opcode, and operand. Okay, what is the mnemonic? Okay, mnemonic actually is the commands. The mnemonic is actually the commands to the CPU, tells that what to do those items, what to do with those items, that is with the operand. Okay, and the optionally it is followed. Mnemonic is followed by 2 or more actually operands, one or two operands, okay, and the data being and data items are being manipulated with that. And given assembly language program actually contains the series of statements, series of the instructions or the lines, and assembly language instructions that actually tells that CPU what to do. So now these are also the pseudo instructions also. There are also pseudo instructions also, pseudo P S E U D O. Pseudo instructions are also used. These instructions are also known as here directives. Pseudo instructions are also known as here directives. Okay, what are the directives? Directives actually, the directive gives the directions to the CPU. So directives gives the direction to the CPU. Okay, so this was the some of the your introduction about the assembly language structure. Now I will discuss this assembly language structure with the help of a program also. Okay, now for the structure of in the structure of assembly language programming, assembly language instruction actually consists of 4 fields. As you have seen on your 16, that the 4 fields are like label, mnemonic, operands, and command. Okay, now one by one, I will tell you what are the function of these. Okay, I have already discussed with you directives also. Okay, so in the first command org, org stands for origin of the program. Okay, means it actually tells the starting location. The starting location is given by the org 0h, that means 0. The starting location is at 0h, 0 hexadecimal. Org gives the directions actually, and these directives do not generate any machine code, and it is only and only used by the assembler. Next is your move R5 comma hash 25h. So as I have already told you, the 25h will be copied into the R5 register. In the next command, 34h is copied into the R7 register. Then move and add. These are the mnemonics. Okay, and mnemonics actually produce the opcodes. Opcode means operation code. The which type of the operation has to be done. Means it should be move operation, it can be your add operation, it can be your subtraction operation, it can be your multiplication operation, it can be your any logical operation, it can be your division operation also. So move and add are the mnemonics produce the opcodes, and move a comma hash 0 means 0 will be copied into the accumulator. Then add the register of add the content of the accumulator and the R5, and final result should be stored into the register A using the command add a comma R5. Then add a comma R7. So this will be add the content of your A and R7, and after that is value at the final that should be stored in the accumulator. Then add a comma hash 12h. So it will directly add the accumulator content to the 12h, and final result will be stored in the accumulator. Now, as you can see, semicolon sign. These all are the comments. So comments are used for understanding the program. If you put the semicolon, then after something written after the semicolon, it will be treated as your comment. And A and R7, A and hash 0, these all are the operands, and mnemonics are move and add. Next is label. Okay, so label, what is label actually? The label actually field allows the program to refer the, actually if you want to refer a line of code by name, so here we use the label. Here colon short jump, SJMP stands for short jump. So this is used for the string this in the loop operation, it will jump and it will always stay in this loop, stay at this instruction only. So here is used as the label field, and this actually label field is used to refer a line of code by name. Then is end. Sorry, end is also as a directive. It shows that the program is ended. Any command written after the end will not be treated as a part, or that instruction will not be executed. And semicolon is treated as comments, and it can be at the end of the line, or you can say line by themselves, and your assembler will ignore the comments. So this was the assembly language instruction structure. It will contains label, mnemonic, operands, and comment. So this was the actually structure of your assembly language. Next, come on to the next topic, that is assembly and running an 8050 program. Okay, assembly and running an 8050 program means how you can assemble and run your program on the 8051. For this, you have to see this diagram firstly. Then after this, I will explain these four in detail. First is actually in the assembly and running an 8050 program, you have to follow the four steps to create a program. First is editor program. Second is assembler program. Third is linker program. And last one is OH program. Okay. So very first step, in the very first step, editor program. Okay. In this step, we use an editor to type our program. You know that editor means editor in which we can edit our program. If you are typing on your computer or laptop, you can edit your data by deleting. So you are also working in an editor. Okay. So editor is used to type our program, and many of the excellent editors or word processor are available to create or edit our program. So in the editor, it should also must be able to produce ASCII file. ASCII code you have already done in your digital electronics. That stands for American Standard Code for Information Interchange. So editor also must be able to produce your ASCII file, and for many assemblers, with actually the file names is actually the source file which is created using this, that is your myfile.asm with the extension as a .asm. Some of the assemblers also generate the .src file. Some of the assembler editor program generates the .asm file, that is assembly. ASM stands for assembly. And some of the editor program generates the file as myfile.src. That depends on the editor program, different editor program. So src also stands for the source file, and this depends upon the .asm extension or the .src extension. It depends upon the assembly, which you are using. Next is here, so the ASM source file create in this step, and the assembler, then this is given to the assembler program. This myfile.asm or myfile.src is further given to the next step, that is assembler program. Now what is the function of this? In this step, the assembler converts actually the instructions into your machine code, that is in the form of 0 and 1, and the assembler will produce two files with the extension .lst, and second one is .obj, sorry. So .lst or .obj. So obj file is your object file, and second one file is your .lst, that is list file. Okay, so it generates the two files. One is object file and second one is your list file with the extension .lst, and object file with the extension .obj. Now the third step is the other object files are also can be called from the external, and these list file, object file, number of the object files, other object files gives to the next step, that is linker program. So in the assembler, the third step is linking. The linker program takes one or more object code files, as you have seen in the diagram. So and it produces the your absolute object file. So with the extension myfile.abs, ABS stands for absolute object file, and this ABS file is used by our 8051 trainers that have a monitor program. Now the last step, the last fourth step is this ABS file is actually given to the absolute file is actually given to the OH program, in which OH stands for object to the hex converter. So means this creates the our hexa file. Object to the hex converter means it will generate our hexa file, hex file that is ready to burn into our ROM. So this programs comes with all the 8051 assemblers, and your recent Windows based assemblers combines the step number 2 through 4 into the one step. Means second, third, fourth step is done only in the one step also. So these are the 4 steps to create a program. So this now going into the detail about the list file. The list file actually that is optional, which is generated by the assembler program, and which is optional. Actually, it lists all the opcodes. It keeps the list of all the opcodes and addresses, and as well as errors that the assembler detected. So the programmer uses the list file to find the syntax errors or debug. Means for debugging purpose we have to use the list file, and which is generated by the assembler program. So further I will show you the list file. So you can see list file is containing your ports, opcodes and addresses. So these all are the addresses, 4 times zeros, then 0002, then 0004, then 006, 0006, 0007, 0008, 0008, 00C. So these all are the addresses, and this is the opcode. Okay, and these opcodes are for this instruction. Means if you have the instruction move R5, #25H, and the opcode for is 70 and 25 is your data. Then move R7, #34. The opcode used is 7F and 34 is data. Then move A, #0. For move A, opcode is 74 and data is 00. For the add A, R5, the opcode is 2D. Add A, R7, 2F, and add A, #12H. 24 is the opcode and 12 is the data. For the short jump here, we have the opcode as 80FE, and last is AND. And the house, these addresses are as you can see, we have started our program with the 4 times 0. Then at the 4 times 0, only 8-bit data is to be stored. So 70 is stored on the this location, and 25 is on the next location, that is 0000001. Then 7F is on the 0002 memory location, and 34 will be on the 0003 location. Then 74 is on the 444 and 00 on the 555. Then 2D on the 6, 2F on the 7, and this is the 2-byte instruction. So 8 and 0008 and 0009 will be memory location will be taken by this. Now you know that after the 999 in the hexa, 10 is written A. Now the next memory location will be 000A. This will also up to 2-byte instruction. 80 will be stored on the 000A memory location. Then the next memory location will be 000B. So FE will be stored on that. And third last, now come on to the next will be 000C. This will be the end of the program. So list file contains the addresses and your opcodes. Now come on to the next concept, that is program counter and ROM space. Next is program counter and the ROM space. Okay, what is the function of the program counter? As you know that in 8051 we have 16-bit program counter. Actually, the program counter points the address of the next instruction to be executed. So it is a 16 bits wide. If I want to write the 16-bit address, then it will be from 4 times 0. So in hexa it will be 4 times 0 to 4 times FH, and having the total of 64K bytes of code, because 2 raised to power 16 is 64. So as your CPU fetches your opcode from the program ROM, then if one instruction or the opcode is fetched from the CPU, then program counter actually increase to the and point to the address of the next instruction. So this is the function of your program counter. And now the next is where actually all the your 8051 members here, when they are powered up, then means they are switched on, then the starting memory location will be of any 8051 members will be 4 times 0. So program counter is initialized at the 4 times 0, and your first opcode will be burned into the address 4 times 0. So if, and this is achieved by the instruction org, means org 4 times 0h. If I will write like this command, then your memory location in which the opcode, first opcode will be written, will be started at 4 times 0h. So whenever any of the 8051 microcontrollers waked up, then this will be at the memory location 4 times h. Then next is here how we can examine the list file and how your code is placed. As I have already discussed with you, at 4 times 0, 70 will be stored. Then at 0001, 25. In the next slide, you can see at 007025, 002 7534, 0004 7400, at 6 2D 7 2F, then 8 2412, and at 8 80 FE. How it will be stored in the memory location, it is shown in the further slide. As you can see, at 4 times 0, code will be stored 70. At 001, you can see next is here 25. At 002, it is 7F. At 0003, it will be 34. At 004, 74. At 0005, 00. then at 6 2D, and 0007 2F, and 000824, then 000912, then 000880, and next is here 00, here B will be FE. So this shows that how your program or your code will be placed in your room memory location, and which is started at 4 times 0, and this is given by the this starting address will be given by the statement org. So this is your this concept program counter and room space, how your room contents will be stored. Okay, how the data will be stored in your room. So next concept is your how your program is executed. How your program is executed. Okay, when your 8051 is powered up, your first memory location is 4 times 0. Then first opcode 7D is for move instruction. Then 25 data is to be moved. Then in the next instruction at 002 7F, then 34 is moved, and this will be incremented to the memory location 0004. Then in the third, the instruction is executed, and now program counter is executed to the next instruction, that is next memory location, that is 006. Then after the 1 byte instruction, it will be 0007. Then this process is going on, and this process goes on until all the instructions are not fetched and executed. And this, the fact that the program counter actually uh, points the next instruction to be executed, that's why this is also known as your instruction pointer. So that's why this is also known as your instruction pointer. Now ROM memory map. Now the next is your ROM memory map. Okay, actually we know that no member of the 8051 family can access more than 64K bytes of code, because we know that the program counter is only 16-bit registered, and if we want to calculate how much memory can be accessed, this will be given by 2 raised to power 16, that is equivalent to your 64K. So in this we have mentioned the I have mentioned the different type of different members of 8051 with their starting address and with their ending address. So in 8751, this is 4 times 020 triple F. In case of DS89C 420/30, that is 4 times 023 triple F. And in case of DS 5032, that is from 4 times 02 year 7 triple F. So you can see that uh, maximum can be your 4 times FFFH if whole the memory is your assessed. But in this case, DS 5032, we can assess 4 times 02 7 triple F. Okay, students, now I will summarize my today's lecture. That is your assembly language. Starting from here, I've already discussed with you that assembly language have 4 feet, that is label, mnemonic, operands, and commands, and directives also. Mnemonics actually produce the opcodes. Label gives the name. If you want to give the name of any line of the program, then this is used. Then semicolon, with semicolon, the comments that are treated as the comments for understanding your program, and the assembler ignores it. And then is your mnemonics are the actually opcodes like move and add, and the directives, which is, gives the directions, means starting of the program, ending of the program, and these are used only by the assembler. So this was the assembly language instruction having the 4 fields. Next, how we can write or run our 8051 program using these 4 steps. One is editor program, where program is written, and this generates the assembly file. Then assembler program gives 2 files, that is list file and object file. This file contains all the addresses and opcodes, and then obj, that is object file. These files are given to the linker program, Then linker program generates the absolute file, and then object to hex file is converted by using the OH program. So these were these four steps to create a program. Next is your list file. I have already discussed with you. It is used for the debugging purpose also, for the finding the syntax errors or the debugging purpose. So in the list file we have all the your addresses and the opcodes and these, and then I have discussed with you in this lecture program counter. So the program counter actually tells about the or the stores the next instruction, points the next instruction, address of the next instruction to be executed. And this is the 16-bit wide and having the 64K capacity memory, and addresses from 4 times 0h to 4 times FFFH. And so whenever your 8051 starts, then starting memory location is your 4 times 0. Then is your after this how your program placed into the ROM code, the different memory location. This is the code, and as you can see that this is the code. ROM addresses. This is the machine language, means that is with the code and the opcodes, data and the opcodes. Then this is the assembly language, and this is the ROM contents. 1 byte at a time is stored in each and every ROM memory location. Now the next is here, when how your program is executed. Firstly 70 will be right, then 25, then 7F, then 34. According to these opcodes and data, the operation will be done. And in the last the program counter is implemented into your 0008 where your program ends. And actually the program counter points the next instruction to be executed. That's why this is also known as your instruction pointer. And some of the ROM memory map, in which like the 8089C51 having the starting address as 4 times 0 to 0 triple F. Then this is your 4 times in the DS89C420/30 series, 4 times 0 to 3 triple F. And in case of DS 5032, it will be your 4 times 0 to 7 triple F. So program counter actually is your 16-bit wide, so that's why different microcontrollers have your different starting and your ending address. So next we will in the next lecture, in the next topic we will do in continuation with the previous one, we will do the next topic, that is your data type. Okay, so in 8051 we have only one data type, that is 8 bits, means we can only deal with the 8 bits data. So your starting address will be 00H to FFH, or in decimal it will be 0 to 255. And data types actually can be your positive or the negative. So in 8051 we have only and only one data type, that is 8 bits. Next is your 8051 data types and the directives. Okay, so DB directive is actually, directives are used for given the direction. DB directive is actually used for the data directive. So it is also it is used to actually define the 8-bit data, and DB defined by is used to define the data and the numbers in the decimal and binary and hex and ASCII format. So D, actually you can see, if nothing is written 28, this is the decimal number, and the assembler will convert this number into the hexa number. And H is written, it means this is the your hexadecimal. If B is written, that this is your binary number. And if double quote is there, so it means that place ASCII in quotation marks, the assembler will assign ASCII code for the number of or characters. These are treated as your ASCII characters. My name is Joe, so this is also your ASCII characters. Means in double quote we have written, that will be your ASCII characters. D is for decimal. If your number is decimal, by default it will be decimal, or you can also write the D, 28D after the decimal. that is optional, but binary hexa for the others is required. Means we should also always mention the binary. For binary number it will be written as B, and for hexa it will be written as here H, and also define these are the your numbers or characters, but this is your string of your the string larger than two characters is known as your string. So my name is Joe is treated as your strings. Okay. Next is your assembler directives. Next is your assembler directives. There are actually some of the assembler directives are there. There are three. There are three assembler directives. One is org, second is and third is equate, EQU. So org stands for origin, and this directive is actually used to indicate the beginning of address. That is, if you are using the starting address as 4 times 0, then org directive is used to indicate the beginning of the address. And if the number is not followed by and your org can be your in hexa or the decimal, and if it is not in the hexadecimal, then your assembler will automatically convert that decimal number into the hexadecimal, because your computer is worked on, or your 8051 is worked on the hexadecimal numbers. Now the second directive is AND. This directive shows that the assembler or indicates the assembler that the your end of the program or end of the source file, that is .asm assembly file, and the end directive is the last line actually. And after anything after written the assembler end directive is ignored by assembler, that instruction will not be executed at anyhow. So next is your equate. Next directive is your equate. So this directive is used to define a constant without occupying a memory location. Actually, equate directives it does not set aside storage for a data item, but it associates with your constant value. Let us suppose when a label appears in the program, the constant value automatically substitute for the label. Means, let us suppose I will show you the one example. From that you will clear this. As you can see, this is count equate 25. So use equate for the constant counter constant 25. Wherever in the program move r3 comma hash count is written the constant, so constant name is given to that. So where in the program count word is written, then it will create automatically the count value as the 25. Not so in this case we should not change the value of the count individually one by one. Automatically it will be created as 25, where it will is seen as the hash count. Okay, so assume that there is a constant in many different places we are using. So if we want to change the its value throughout in the program, so by use of the create statement we can assemble, we can change it once, and the assembler will change all of its occurrences. Means at all in all the instructions where it will see the hash count, then it will create the value 25. So in the now this completes the 808051 data types and the directives concept. Now in the next lecture we will do the 8051 flag bits and PSW register. So we will meet in the next lecture. Till then, take care. Thank you.